In this video, we provide a lesson overview of lesson 9.1, which is all about making inferences about two proportions. These slides are based on slides provided by Pearson to accompany our text and then modified by me for our course. This material is from chapter 9, which is about inferences from two samples from Essentials of Statistics, 6th edition by Mario Triola. Inferences about two samples are really important because often we want to know how effective a drug is. So we'll compare a treatment group and a placebo group, or we'll want to make generalizations about the differences between groups. So if you've ever taken a class in psychology and they say men tend to act like this and women tend to act like that, you might be asking yourself, how do you know and how did you measure that? Well, they measure that using probabilities and they test those hypotheses using statistics. So anytime we're making a comparison between groups, the methods in chapter 9 are appropriate. This is a great place to start if you want to compare two groups. In lesson 9.1, we're going to make inferences about two population proportions. In lesson 9.2, we're going to make inferences about two means. In 9.2, those samples will be independent samples. I believe 9.3 is related to making inferences about two means when the samples are dependent. Unfortunately, due to time constraints, during the fall 2020 semester, we are not covering 9.3, but there's a lot of great information in your book that you can learn on your own if you're interested, that extends what we're studying in 9.1 and 9.2 to other applications. Now, you can also think of everything that we're doing in chapter 9 about inferences from two samples as extensions of what you learned in chapters 7 and 8 about hypothesis tests and constructing confidence intervals. So that's pretty much what we're doing in both lesson 9.1 and lesson 9.2 is we're conducting hypothesis tests and we're constructing confidence intervals. So here are our key concepts for lesson 9.1. First, we're going to present methods for testing a claim about two proportions. And when we're testing that claim, we'll use either the p-value method, the critical value method, or the confidence interval method in order to test that claim. And then second, we're going to learn how to construct a confidence interval estimate for the difference between two proportions. I'll want you to be able to describe how these methods are similar to each other and different from each other, why we use the formulas that we use, and which methods will give you equivalent or considered to be equivalent because they give you the same conclusions. After all of that, we'll talk about what to do when the requirements for using these methods are not met. So we do have a short list of requirements. If they're not met, it turns out that there are things that we can do to test a claim about two population proportions or construct a confidence interval estimate. And we'll talk about those at the very end of lesson 9.1. Now, here are our learning outcomes. With our first learning outcome, my goal is really for you to understand what you're doing and why you're doing it. So after watching this video, my hope is that you'll be able to describe the rationale between or behind the p-value method and the critical value methods for testing claims about two proportions. And I'll also want you to be able to outline the basic procedure for hypothesis testing. We'll do all of that in the video for 9.1.1. Then I'll want you to be able to describe the test statistic, the distribution of p sub 1 hat minus p sub 2 hat, the pooled sample proportion, what it is and why we're using it, and how all of these relate to hypothesis testing. Again, this learning outcome number 1, which is described in video 9.1.1, is not about applying anything yet. It's about outlining what we're going to do and talking about why we're doing it. I want you to focus on that and this learning outcome because it's going to make everything else that we do in lesson 9.1 make a lot more sense. So after we learn what we're doing and why we're doing it, we're going to apply that to test a claim about two proportions using the p-value method. With this learning outcome, we're actually working out a problem that is very similar to the problems that you'll see in your homework or on exams. In learning outcome number 3, we'll test a claim about two proportions using the critical value method rather than the p-value method. Then in our fourth learning outcome, we'll learn to construct a confidence interval estimate of the difference between two population proportions. My goal for you is that you'll be able to describe the rationale behind the formulas and then discuss the difference between the p-value and critical value methods and the confidence interval method for testing a claim about a difference between two population proportions. And then in our last learning outcome, we'll discuss the options for testing hypotheses about two proportions when the requirements for critical value method, p-value method, and the confidence interval method are not satisfied. We'll also talk about how you can construct a confidence interval when the requirements are not satisfied as well. So that's it for our introduction to lesson 9.1. I will see you in the first video to discuss the rationale behind all of the formulas that we use for hypothesis testing. And it turns out to have to do with that sampling distribution of p hat that we discussed back in chapter 6. So I'll see you then.